Good morning, dear children. Now we will move to our next topic, principle of moments. What was moment of force? The turning effect produced by force can be called as moment of force, isn't it? That is, when you are applying force on a pivoted body, a turning effect will be produced, and that is moment of force or torque. Now, just consider a body which is pivoted at a point. Okay. Let number of forces act on that body. We are considering a body which is fixed at a point. So let this be the axis. Okay. Let number of forces acts on this body. So let this be F1, this be F2, F3, F4, F5. Okay. Let 5 forces act on this body. Now, what will be the resultant force or the net effect on the body due to these forces? What will be the net effect or the resultant of all these forces? So, resultant means what will we do always? We will just add it, isn't it? That will give you the resultant. But the thing is, here the body is pivoted at this point, and these two forces F1 and F2 tends to move the body in, which is this direction, anti-clockwise direction, whereas F3, F4 and F5 will tend to move the body in the clockwise direction. Okay. So, we are having 5 forces acting on this body. The two forces F1 and F2 will tend to rotate the body in the anti-clockwise direction, whereas F3, F4 and F5 tends to rotate it in the clockwise direction. So how will we take the resultant? That is, resultant means what? What is the net effect on the body due to all these forces? Okay. So how will we take the resultant? Resultant means adding up, but the thing is 2 forces are acting in the anti-clockwise direction and 3 forces are acting in the clockwise direction. So we already learned that anti-clockwise direction is always taken as positive and clockwise direction is taken as negative, isn't it? Anti-clockwise is positive and clockwise is negative. So what will be the resultant? F1 plus F2. F1 and F2 acts in the anti-clockwise direction. So we will be taking it as positive, whereas F3, F4 and F5 are acting in the clockwise direction. So these 3 forces will be taken as negative. So this will be the resultant force. Okay. So once again, when you are considering a number of forces, if more than one or many number of forces are acting on a pivoted body, the resultant force will be the algebraic sum of the individual forces. Algebraic sum, here you have to consider the direction. Okay, that is why we are calling it as algebraic sum of the individual forces. So here F1 and F2 are acting in the anti-clockwise direction. We have already learned that anti-clockwise direction is always taken as positive. That is why I have taken F1 plus F2. Whereas clockwise direction is taken as negative. So we have F3, F4 and F5, which will be taken as minus. So F1 plus F2 minus F3 minus F4 minus F5 will give you the resultant or the total force acting on this body. Okay. Now, according to we were discussing about principle of moments. According to principle of moments, if the algebraic sum of all the forces acting on a pivoted body is 0, okay, if the sum of all these forces is equal to 0, then the body will be in equilibrium. Okay. If the resultant of all the forces or the algebraic sum of all the forces acting on a pivoted body is 0, then we can say that the body is in the state of equilibrium. So what was equilibrium? Do you remember equilibrium? If number of forces acting on a body cannot change the state of that body, you can call it as equilibrium, isn't it? So when you are considering a body and if many number of forces are acting on it, but there won't be any change in the state of rest or motion of that body, then you will say that the body is in the state of equilibrium. So if many forces are acting on the body, but if the resultant is 0, then you can say that the body is in equilibrium. That is, no change will be there in the state of the body. And this is known as principle of moments. Okay. So according to principle of moments, if the algebraic sum of moments of all the forces acting on a pivoted body is 0, then the body will be in equilibrium. Okay, or you can say that if the sum of anti-clockwise moments is equal to sum of clockwise moments, then the body will be in equilibrium. If F1 plus F2 is same as F3 plus F4 plus F5, if both the sides LHS and RHS are equal, means it gets cancelled, isn't it? So net result will be 0 and then the body will be in the state of equilibrium. So is it clear? What is principle of moments? If the resultant or the algebraic sum of all the forces acting on a pivoted body is 0, then the body will be in equilibrium. Now, an example for this is physical balance or beam balance. Okay, physical balance or beam balance works on this principle. So, I think you know about a physical balance or a beam balance. There we are having a horizontal rod and two pans will be hanged on the ends. So if you are keeping equal weights on both the pans, then what happens? The rod remains horizontal, isn't it? That means again it won't move, it remains stationary. That is, it is in equilibrium. So in that case, when you are considering this as a balance, physical balance, then how much weight you are giving on this side, that will tend to rotate the body in the anti-clockwise direction. If you are keeping the weights on right side, it will tend to move the body in the clockwise direction. Once the weight on both the sides are same, then the beam will remain horizontal. Okay, that means if anti-clockwise moment is equal to clockwise moment, then the beam will be horizontal, that is the body is in equilibrium. Okay, so what all things you should keep in mind? What is principle of moments? Then an example for principle of moments, that is physical balance or beam balance. Okay, so when you are hanging weights on a pivoted body, those weights will tend to rotate the body. If the sum of the weights or sum of the moments produced by the weights is 0, then the body will be in equilibrium. Okay, so I hope it is clear. According to principle of moments, if the resultant of all the forces acting on the body is equal to 0, okay, many forces can act on the body. If the resultant of all these forces, algebraic sum, resultant means here you are taking algebraic sum, that means you have to consider the direction also. If the algebraic sum of the moments of forces, okay, algebraic sum of the moments of forces acting on a pivoted body is 0, then the body will be in equilibrium. So once we verify this, once we do the verification, it will be clear for you. Okay, so now we will move to the verification of principle of moments, and with that we have many numericals. Okay, so for this we are taking a meter rule. So what do we mean by a meter rule? Meter rule means a scale of length 1 meter. Okay, a scale of length 1 meter can be called as a meter rule. We are taking a meter rule which is hanged on a rigid support. Okay, so when you are hanging in a meter rule, here actually meter rule means 1 meter or 100 centimeter. So we will be hanging it at the 50 centimeter mark. Okay. So this meter rule is hanged at the 50 centimeter mark. Here it is 0 and here it will be 100. Okay. So what about the position of this? This will remain horizontal because you are hanging it at the exact center. Okay. So this meter rule will remain horizontal. Now using spring balance, you can hang two weights at the ends. Okay. So let this be W1 and this be W2. Using spring balances, we are hanging two slotted weights W1 and W2 at the ends. Okay. If W1 and W2 are same, okay, if these weights are same and if these two things are or weights are hanged at the end points, means this beam will remain horizontal. Okay, suppose these weights are not same. W1 is not equal to W2. Then when you hang this, what happens? Will it remain horizontal? No. At that time, it won't remain horizontal. Then one side will go down and the other side will go up based on the weight. So if more W2 is having more weight than W1, then what happens? This side will go down and this side will go up. So if such is a condition, that is if W1 is not same as W2, what you can do is just move the position of the hanging of the weight. Okay, at first we have hanged the weights at the ends. Now instead of that, just move the position, and at a particular position when you hang this weight, what happens is the beam will remain horizontal. Okay. So once again, at first I have taken a meter rule, uniform meter rule, a 1 meter scale. It is hanged at the or suspended at the 50 centimeter mark. Okay. Then I have taken two weights W1 and W2. These weights are hanged using spring balances on the ends. Okay. Now, at first, if you are considering these two weights are same, if W1 and W2 are same, and if you are hanging at the ends, the beam will remain horizontal. Now, if W2 is having more weight, then what happens? This side will go down. The side with more weight will go down, isn't it? Then, if you want to balance the rule again, what can you do there? Just move the weight and check. So when you move the weight, what happens at a particular position of the weight, you can see that both the rule will remain horizontal. Okay, so at that time you can stop there. Now, let this length be L1 and this length be L2. Okay. L1 is the distance between the point of suspension as well as the point where the weight is hanged. L2, same thing. Point of suspension and the point where W2 is hanged. Now, due to weight W1, which type of moment is produced? Weight means it is actually force, isn't it? So, due to weight W1, this part will go down, that is anti-clockwise moment will be produced here. Okay. So what is anti-clockwise moment here? Anti-clockwise moment, let me name it as A and B. Anti-clockwise moment about A. What is the equation for moment of force? Moment of force is given by force into distance between point of suspension or the axis of rotation and the position or the point where the force is applied. That is what we have learned in the beginning, isn't it? So, moment of force is given as the product of magnitude of force and the axis of rotation. So, due to this weight actually tends to rotate this meter rule in the anti-clockwise direction. So anti-clockwise moment about A will be equal to, what is the force acting here? Weight, isn't it? So this is the force. Force is weight into distance between the point of application of force, that is A, and the axis of rotation. The body will rotate about the pivot, isn't it? That will be considered as the axis. So what is this? L1. So anti-clockwise moment is W1 into L1. Now what will be the clockwise moment? Which part will be rotating? This side. Due to weight W2, this side will be undergoing clockwise moment, isn't it? So clockwise moment about B will be equal to, the weight is W2, then the distance is L2. Okay. So is it clear till this? When you are hanging the weights on a ruler, it will tend to rotate this. Since the ruler is fixed at a point, these weights will tend to rotate the ruler. So when you are hanging a weight on this side, naturally the turning effect or the rotation will be in the anti-clockwise direction. Here it will be in the clockwise direction. So we are calculating the moment of force produced on both sides. So here, since it is anti-clockwise moment, I have written like that. Anti-clockwise moment, when you calculate moment, always use the equation force into distance. So the force is weight and this is the distance. So W1 into L1 and W2 into L2. Now what will be the total moment of force here? Or no need to consider total moment. What are we going to do? We are verifying the principle of moments. What was principle of moments? According to principle of moments, now when I have kept the object here, the rod is horizontal. That means it is in equilibrium, isn't it? So according to principle of moments, the algebraic sum of the moments of forces should be 0, or you can say that sum of anti-clockwise moments is equal to sum of clockwise moments. So that means W1 L1 is equal to W2 L2. When W1 L1 will be equal to W2 L2 if the body is in equilibrium. Okay, so if the body is in equilibrium, W1 L1 will be equal to W2 L2. So this is how we can verify principle of moments. Now, no need to by heart the verification, but you should know this because many numericals are there based on this. Okay, so we have learned the principle of moments. According to principle of moments, if many forces are acting on a body in equilibrium, if there are many forces, okay, if many forces are acting on a body which is pivoted at a point, then when you are considering the resultant, that is the total force or the total effect of these forces, and if that is 0, that means the body is in equilibrium. So that is what we have proved here. We have a uniform meter rule. We have taken 2 and this rule is suspended at its center. Now we have taken 2 weights W1 and W2. These weights are of not same. Okay, one weight is more than the other one. It is not same. So when you hang it on both ends, what happens? The rod won't remain horizontal. If the rod remains horizontal, then only you can say that it is in equilibrium state. So we have moved the weight, we have changed the position of the weight. So at that time the rod remained equilibrium. So according to principle of moments, at equilibrium the sum of anti-clockwise moments should be equal to sum of clockwise moments. Here only one weight is there. So I have taken it as W1 into L1 because the equation for moment of force is force into distance. So W1 L1, here it is W2 L2. So since these two are same, product of the force as well as distance should be same as the product of the force and distance in this direction. If both are same, then the rod will be horizontal. Okay. Now, if I am taking one more weight here, okay. If I keep one more weight here, will the rod be balanced? No. At that time, this side will go down. So what you can do? You can again move the position of the other weight. So by changing the weight, you will get the rod in a horizontal manner. But at that time, what you have to write as the equation, W1 L1 plus, sorry, this let it be W3 L3. Okay, already we have W2 and L2. W3 L3 will be equal to W2 L2. So when we do the numericals, this will be clear. So always what you have to keep in mind, if the moment of force, just find the moment of force in both the sides. Okay, that is moment of force in the anti-clockwise direction as well as clockwise direction. If both are same, then the body will be in equilibrium. Okay, so thank you.